Right, hello. I want to talk just briefly about some basic algebraic techniques. I know algebra has a sort of reputation among some people for being hard or whatever, but I think for starters, it would help if you're okay with the basic arithmetic principles, because that's basically what it is, really. It's taking the arithmetic and using it in a more abstract form. And at the same time, okay, whether you think it's hard or not, ultimately you're going to end up being using it mostly to solve equations. Well, I say mostly, a lot of the time solving equations. And if you've got to solve an algebraic equation, then you end up with an answer which you can then substitute back into your the original equation you're given, and you can test whether the answer you've derived actually is or actually does satisfy the original equation. So therefore you can immediately tell whether your answer is correct or not. And in that sense, you would be hoping there's at least a way there to get full marks if you can self-check your answers. So it's in that sense it is worthwhile taking the effort to learn this topic. So as I say, normally, well, again, other things you probably know, quite commonly we make use of symbols like X and Y. But if you've been listening to some of my previous videos, I've also been using sort of abstract algebraic type formula. Anyway, I talked about the area. Well, the area would equal AB possibly if you declare AB to be the two sides of a rectangle, or you could have a cuboid shape which you could class as ABC. So that you've got their formulas in an algebraic form. And again, probably, well, I did mention at the time that essentially the multiplication sign is implied. So that means A times B, and that means A times B times C. You don't need to put the multiplication sign in. And that's useful because you can then think of this object as being, a sort of independent object, if you like, which it is really, isn't it? That's the area, and that's the volume in these particular examples. So you can have all. Obviously, well, when I say obviously, you can have mixtures. You can have an algebraic term like that, or you can have x squared y, or 2xy, or anything you like. So as I say, if you've had an expression like I don't know, two. Say I was trying to multiply two terms. Now that's, as I said before, that's not particularly favoured because we commonly use x's in algebra. So if you're going to use a multiplication sign like that, then it's going to cause confusion. So we would like to have not to use the x sign for multiplication in algebra. And if I can simplify that. Well, if I was to, I could write it alternatively as say 2a 3b. That's very clumsy, but it follows the logic I've just said now, that would, as a term, that would be 2 times a times 3 times b, which is essentially the same as that. What I could do if I wanted to make things a bit clearer is to use a dot like that. That would be, a dot indicates multiplication. Or alternatively, I could use something like this. That would indicate multiplication as well. So you got these two alternative forms, and that is not particularly one you should be using in algebra to denote multiplication. Yeah, but this can be simplified out of this slightly clumsy method, because I can multiply the 2 by the 3 to get 6. So I can say 6ab. Okay, so that's when you think about it, that's just again, it's just an abstract, a more abstract method of what follows in arithmetic. If you had a string of I know 2 times 3 times 6 times 9. You know, I can multiply that by that if I want. I mean, obviously I can multiply the whole lot, but individually I can multiply that by that and say 2 times 18 times 9, and so on. So that's essentially just what I've done here. I'll multiply the 2 by the 3 to get 6ab. When you try and add expressions to, okay, I've just been talking about multiplication, but when you get two terms added together, the urge for a lot of people who've just coming new to this subject is to try and merge various terms into one, but you can't do it here. You've got two separate things. You've got 2 of an object called A and 3 of an object called B, and you just can't simplify that expression at all. I mean, this A could stand for anything. It could stand for apples, and this could stand for B could stand for oranges. So you have 2 apples and 3 oranges, and that's all you can do with it. You can't simplify it down any further. I mean, if it was 2A plus 3A, that can be simplified because it's just 2 of something. What it is, it doesn't really matter. It's just 2 of something called A and 3 of something called A as well. So that would be 5A. Whatever A is, if you've got 2 of them and they add 3 more of the same, then you're going to get 5A. 5A. Probably should mention in passing that if you have something like x plus 3x, that equals 4x, because the convention is that actually stands for 1x. So you've got 1x plus 3x equals 4x. You've got 1 of something plus 3 of something. And, if you've got 1 of something and 3 of something, then that will sum to 4 of whatever it is. And these can get more difficult, an expression like that. Again, if you can follow on from what I just said and think of these xy's as sort of an object by itself, you've got 2 of them. You've got 2 of an object called xy, and you've got 3 of an object called xy. So you'll have 5 of that particular object called xy. Right. I'll say this is just going to be a quick, brief introduction to the topic. But if I can sort of, say if I have an expression like this, 3ab. I mean, this is a bit more like what I was saying before, that people, when asked to simplify something like that, people will rush in and try and simplify it down to one single term, which you can't do, but you can simplify it down to 2 terms, because you've got an object here called x squared y, and you've got another object here called x squared y. Those are the same objects, and you've got 2 of them here, and you've got 4 of them here, so that will sum to 6 of them. So I've got 6 of that particular object called x squared y, but that 3ab stays as it is. So that is a simplification of that expression on the previous line. If I had something like 2, right. Although it might not seem so at first sight, what you've got there is two objects are the same. All that's different here is that they are in different order. But I mean, that doesn't make any difference. Just as just as 2 times 3 equals 3 times 2, then y times x cubed equals x cubed times y. So you can add them together. I mean, I'll write them out in a modified form before I do that, just to make it clearer. What I've done here is I've decided to change that into that form because it's conventional I mean, it's not necessary, but it is conventional to have these in alphabetical order. You'll have the number on the front, and then you'll have all the unknowns in alphabetical order. But so therefore, it's, as I said before, it's just 2 of them and 4 of them, so it's 6 of that particular object. Yeah, so I mean, I don't know whether I need to really ram this home here, but perhaps I could have given an example of using purely numbers. I mean, if I had to simplify that, I don't simplify it down to a single number, can I? But at the same time, I can simplify 2 of those. I can simplify that expression there. So x will stay as it is, and that become well, plus 1. So that would be a simplification of the line beforehand, just by simplifying the numbers. So in the same way, you can just apply that method to simplify more abstract algebraic terms. So that's probably enough as a very brief introduction to sort of simplifying algebraic terms in general. So yeah, thanks again if you're still with me, and see you again.